Okay, problem 5. Hopefully this won't take nearly as long as the previous two. We have a ball rolling horizontally off a tabletop that is a certain height. So let's draw a little table there. And we're going to say the height is, the tabletop is h, and the ball lands at distance d from the edge of the table. Or, yeah, right. Of course, we neglect air resistance. We always do. So there's the ball as it falls. Doom, doom, boom. How long was the ball in the air? Well, that's not very hard. Really, what's happening here? I mean, we can do the whole thing where we define a coordinate system. So let me just, for the sake of funsies, we'll put y there and x there, and then we can say, fine. So y naught equals h, and vy naught equals 0 because it rolls straight horizontally off the edge, and the acceleration of y is of course going to be negative g. So y equals h, and then there's no initial y naught, so we ignored that part, minus 1/2 gt squared. And then it hits the ball when y equals 0, hits the ground when y equals 0. The relative factors are doing part A, so t equals, well, I mean, let's take this equation and then just go with h equals 1/2 gt squared, and then t equals square root of g, and then it's so it's what, 2h over g, right? Nothing particularly difficult there. I'm just going to go ahead and do part B. Part B, what was its speed at the instant it left the table? Well, the speed, I mean, it covers distance d, so really we can just use delta x equals v sub x times the t it spends in the air. Because the thing is that, acceleration in the x direction is 0. And so velocity in x equals the initial x velocity forever. And then, so then this is our movement at x equals x naught, which was 0, plus v sub x naught times t. So, whatever. We can just call that, actually, we can call vx naught, we can call it v naught. So that's fine. So I'm going to find v naught because when it leaves the table, its initial velocity vector is just that initial speed it had times I hat, because all it's doing is, rolling to the right. It's just going straight that away. So pretty easy then to basically take this and say, v naught equals vx equals the distance it went in the air divided by the time, so it keeps its velocity the whole time it's in the air, it just keeps moving to the right. Boom. So v naught is d over t, which is d over that lovely little square root of 2h over g we had before, which is then equal to d square root of g over 2h. So we're just taking that and inverting it. This is a g as ugly as it looks. And then, so we can just say v naught equals, if we want to put it all inside the radical, we can do d squared g over 2h. Oh, fascinating, fascinating, fascinating. So, let's see what happens when we plug in numbers. My numbers were, let's see, h equals 1.8 meters and d equals 1.54 meters. Actually, my height was 1.0 meters, so, okay. So this gives us t equals, and I'm just going to pull the old calculator out. Okay, and let's see, 2 times h 1.8 divided by 9.8 meters equals that, and then we square root that, and so the time equals 0.606 seconds. 0.606 seconds, and then my initial velocity was then d squared, so 1.54 x squared, so d squared times 9.8 times 9.8, 9.80, fine, whatever, divided by 2 divided by 1.80 equals that, and then take the square root of that, and so V naught was 2.54 meters per second. So V naught equals 2.54 meters per second. This was probably unnecessary actually, because I really could have just taken, I knew delta x was, I knew basically right here, I could have just done that because I already knew t, so just take the 1.54 and divide by 0.606, so, whatever. So, moment of truth, let's see what we have. What was it, 0.606 and 2.54, 606 and 2.54, and submit, and page down.